this our own price effect, the price of our product on purchasing us. But we also have this cross price effect. This is the price of, this is the effect of Hunt's, this is the effect of the price of Hunt's on the probability of purchasing our product. It also has the cross promotional effects. These are the effects of Hunt's promoting on our probabilities. So while, and again, think about what's going on. So if we start with the base, while our promotions should increase our probability, their promotions should decrease, should shift us back this way, should decrease our probabilities. So we want to measure the effects of not just our promotions, but of our competitor promoting, and see how that affects us. And of course, we're going to graph it, which is what we do. All right, I'm going to do this less than this table thing. Compare the first half. These are the price coefficients. So, price of Heinz, and again, the dependent variable is the probability of purchasing Heinz. Pretty similar, 75 versus 78. And again, the interpretation of that is kind of awkward. It's the change in the Z statistic associated with purchasing. The promotional effects. The dummy, it looks like, goes from 47 to 66. For feature, 05 to 01, and changes sign. Feature and display changes from 1.5 to 103. So things are changing a bit. And then we got the, yeah, these are still Heinz interactions. 26 versus 22, 8 versus 7, those didn't change much. Feature and display, 30 minus negative 30, negative 20, those are all slopes. And let's look at the Hunt's effects. So, first one is the price, the effect of the price of Hunt's on the probability of purchasing Heinz. Should that be negative or positive? So the cross price effect, I think we've done this. The cross price effect is the change in the probability of purchasing Heinz resulting from a change in the price of my competitor, Hunt's. Should this be positive or negative? So it doesn't do everything. Let's think this through. If the price of Heinz goes up, what should happen? I'm sorry. If the price of Hunt's goes up, what should happen to the probability of buying Heinz? Goes up, right? Why? Because the law of demand should hold. If the price of Hunt's goes up, people are going to buy less Hunt's. If they're buying less Hunt's, what are they going to buy? More Heinz, exactly. And the same thing is the opposite is true. If the price of Hunt's goes down, law of demand holds. They're going to buy more Hunt's, and if they're buying more Hunt's, what are they buying? Less Heinz. So again, that goes down. The signs are always going to be the same, so if this is positive, if this is going to be positive, if this is negative, it's going to be negative, and they'll cancel out and be positive. So, all that, we got a positive coefficient, that's good. Our cross price effect is of the expected sign. Our promotional effects should be negative on the probability. Our promotional effects by Hunt's should be negative on the probability of purchasing Heinz. And as we see, remember the intercepts are not as important, but most of them are negative except for spread. Again, the easiest way to examine these is to graph. And what we want to do is specifically analyze our promotional effects one at a time. So notice we're still going to use the over, feature, and display. Where's the command I'm looking at? It's here. But I want to specifically put feature hunts, display hunts, and feature and display hunts set equal to 0. And here's the trick with margins. If you don't specifically set stuff equal to either a value, it's going to set it equal to an average. What does that mean? It means that if we don't specifically set hunts' promotional aspects to 0, then it's going to set them to their average value, the average between being 0 and 1. And that has no meaning to it. It's a promotion. It's either being promoted or it's not. It can't be averagely promoted. It's yes or no and not average. So we have to specifically, if we want to analyze the effect of Heinz's promotion, we have to specifically set Hunts's promotions equal to 0. So all those graphs we looked at before, we're assuming that Hunts's promotional aspects were set at their average. And that's probably not right. Well, it's not right because it didn't make any sense. And as we can see, it's taking a little bit longer. So this is just Heinz's promotional aspects. We're not getting much different results, but they are different. I mean, if we were to actually compare the numbers, they are going to be different. We're still getting the effect of feature and display being ineffective. And there are some minor differences. If we put the graphs together, do I actually put the graphs together? You can see the difference. Sometimes you can get vastly different results, though, which is really scary. Shoot, okay, so now we're going to do the other thing. We're going to evaluate the effects of our competitor promoting while setting all of our promotional features aspects to 0. So this is, again, the pure effect of Hunt's promoting when we're not promoting. And we can specifically say that because we've specifically specified that. Specifically. Should do specifically as many times as possible. There's another drinking game for you. Every time I use the word specifically. Took a shot. And again, we'll do the same thing we did last time. Kind of far off here. Is it? Just getting excited about all this stuff. Everything's the expected direction, at least. Directionally, it's all the same. Again, our base is blue. Red is featured displayed by Hunts, and it's having the biggest negative effect. So that makes sense. When Hunts is on feature and display, it's really having a negative effect on the probability of choosing our product. It looks like green is display. That has the second biggest effect. And then mustard or yellow, whatever you want to call it, is feature, and that's having a relatively minor effect. But everything's in the right, is the right sign and right direction. And these ones make sense. At least, like I said, feature and display are having its biggest effect. And we're still going to investigate what's going on with Heinz's feature and display. But for now, we got good expected results. So again, left the labels unlabeled so that we can make sure we label everything correctly. And we can construct our legend. trace out the confidence intervals. We need to see again. Sure. You only live once. You can see these ones aren't all over the place. So the confidence of these results, yeah, you can see how much tighter these are. But the other ones were going down into the negatives and just shooting all over the place. So, well, we weren't as confident in the effects of Hines. These confidence intervals are much smaller, much tighter, and we probably have a lot more confidence. We can say a lot more confidently that Hunts's promotional effects are detrimental to Hines than we can say Hines's promotional effects were positive in increasing their probability. So at least half of our analysis is confidence in. And it's really not our analysis, it's half of our results. Like I said, it could be that we just don't have enough data to analyze those promotional effects. Let's see what we're doing. These individuals. Yeah, these are just analyzing them individually. And we don't need to do that. Display. Yeah. So hypothesis testing, I think we did this last time, but we'll do it again. So here's our full model. And again, these are those kind of standard hypothesis tests. Can we test whether, for example, if we saw that feature and display, so here's our non-promoted, and feature was here and display was there, can we test whether or not feature and display are statistically different from each other? So how do we do that using our logit and/or probe? Let's skip this because I'm just going to give you the commands anyways. So here we go. So this is our full test. So basically, I set everything equal to 0. I set all the promotional effects by Hines equal to 0, including the dummies and the interactions. So this is testing whether or not all of our promotional aspects are statistically equal to 0. And we're getting a relatively small chi-squared statistic. And again, here's our p-value. Remember, for p-values, we want something small, usually less than 5%, or at least 10%. This is 18%, so we reject the null hypothesis that all of our promotional efforts are ineffective. Again, we're not rejecting by a whole lot, but we are rejecting. So there is there are some positive effects of promotion by Hines. Again, we're going to investigate that, because I think that's going to be fascinating. Can we do the same for Hunts? Yeah, this is just our hit rate and all that other stuff. Logit model. Rock curve, we did that. One of the things that we haven't looked at is reason for this is the price of hunts. Right? Looking at all these dummies is pretty easy because dummies are pure shifters. They're shifting it out for promotion by Heinz. They're shifting it back for promotion by Heinz. Looking at dummies is easy. Looking at this cross price effect is a lot more difficult. The reason is that you can really only have two quantitative axes in two-dimensional space, right? We've got a probability here, and we've got a price here. So again, shifters are going to shift out this way, promotion by Heinz. Shifters are going to shift out here, this way, promotion by Heinz. And interaction, it'll change the slopes and all that kind of good stuff. To analyze a third variable, a third quantitative variable, we would need a three-dimensional graph so that these are now surface planes with mounds and those kinds of things. Those are, believe me, I've seen people try to present those. I never have, but I've seen people try to present those. Those are really hard to understand. They're just really hard to understand. You've got to, the way I've seen it, it's you're looking at these things and they're trying to rotate them to get you to see how this three-dimensional plane has a mound here and that represents the increase there. It's awkward. You really have to drop some acid and listen to some Pink Floyd or something because it's really hard to comprehend. And you can do that on your own time, but I recommend not doing it in class. But one way of doing this without doing this is including our competitor's price is actually a pretty simple solution. Look at the price difference. Just take the price difference. So let's kind of summarize these prices real quick. I just want to see the difference. So it looks like the average price of this lower is Hunt's. Looks like the average price of Hunt's is about 3.3 cents per ounce. The average price of Heinz is about 3.5 cents per ounce. So there is a small price difference. The maximum price for Hunt's is a little bit higher, I guess 8.7 cents. And the maximum price for Heinz is less than that, which is interesting in itself, even though it has a slightly higher average price. Do I graph them? We can test to see if they're different. Here's a t-test. So this is kind of like running a regression on these, but we're doing a hypothesis test on the difference between the two means. Right? Here's the price of Heinz, the 35, and here's the 33 for the price of Hunt's. The difference is this. Is this difference statistically significant? It seems small, but is it statistically significant? Well, it's got a t-stat of 6. So that means that that difference is statistically different from 0. So there is a difference in prices between Heinz and Hunt's, and it looks like Heinz is on average a little bit more expensive. And again, we can do this test statistically to answer that specifically, to take a shot, to whether or not those are different prices. We could try to graph these. I have a better graph of this. Try to graph these. This is the graph of Heinz. This is a graph of Hunt's. So we kind of want to see what, on average, what's going on. And clearly they're different. And we can combine these two. And again, it's kind of awkward. We see the distribution for Heinz is a little bit more spread out. The different distribution for Hunt's is a little bit more tightly distributed. But it'd be nice if we can have a much more, compare them a little bit more closely. We can use a box plot, and you know I love box plots. And who doesn't, by the way? So, dropping acid. And these are kind of hard. Again, we just see kind of the wider distribution here and the tighter distribution here. That middle line is the median. Those look pretty close. We know the means are different, and the means are statistically different from each other. Those medians are pretty close. We can actually test those medians, but we won't do that. So here's what I did. I think that's cool. Let me run it first, and then I'll show you what I did. I think I did this before. Have I done this before? Overlay two graphs?
Yeah.
Oh, I have. In this class or 5A?
Last class.
Last class?
Last week.
Oh, okay. So we're doing this again. And here we can, was it the same example? This, was it?
Yeah, I think so, yeah.
Oh,
I mean, ooh, this is new.
Yeah, these fake
I
it.
mean, hey.
But you can see that Heinz is in the red, and you've got, and again, on average, Heinz is more expensive. So you can see it's got, the histogram it's got more frequency on this end than Hunt's does, which has less of a frequency. And Hunt's is more highly distributed at these at those middle prices than at those middle prices, where Hunt's frequencies, at least in terms of percentage of prices in those price categories are a lot less. So I like overlapping these. It's kind of nice. So what we want to do is, so we know there's some price differences. I'm going to generate a price difference. And it's simply that. It's D price Heinz minus Hunt's. And it's simply the price of Heinz minus the price of Hunt's. And I'm going to use that in my regression. And again, this is a simple regression. And I think this is a lot easier to understand than a three-dimensional graph. Oops. So I changed my dependent variable to the difference in prices. And again, this makes perfect sense because as the price of Heinz is more expensive than Hunt's, the probability of purchasing Heinz goes down. As the price of Heinz is less than that of Hunt's, the probability goes up. So now we're able to have a third quantitative variable in a two-dimensional graph without having to imagine surface planes, which is a lot more convenient. So looking at these price differences gives you another way of, again, analyzing what literally, what can be interpreted as these cross-price effects. When my price gets high, my probability goes down. When my price gets low, my probability goes up. So it's not truly a cross-price effect, but we're able to kind of incorporate some of those cross-price effects, incorporate that third dimension into our analysis. And we can add all of our promotional aspects. All right, which is what we get here. So the first one we look at is Heinz. When Hunt's does not promote, so I'm going to set all my Hunt's stuff to 0. And go over my Heinz. So basically, I'll almost all of my margins, commands, and graphs are going to be the same. Except I changed my dependent variable from price of Heinz to the difference in the price of Heinz minus Hunt's. So what do we see here? We get a different perspective. Interestingly, again, the promotion effects by Heinz, holding all of the promotions by Hunt's constant at 0, have their bigger effects when the price of Heinz is more expensive. And interestingly, yeah, which is interesting. Promotion has a bigger effect when Heinz is more expensive than Hunt's. I guess that makes sense. It's kind of counterintuitive. Usually price and promotion go together, which we're going to have to address also. We can analyze those same Hunt's promotions now. Now we're going to set all of the Heinz promotions equal to 0 and analyze the negative impact of the Hunt's promotion. And we get now we're seeing, again, it's another angle, but now we're seeing that feature and display are really pretty close to each other. I know, we can test those for statistical significance, whether or not they're different from each other. Feature and display by Hunt's is having the biggest negative effect on the probability of purchasing Heinz, but these two effects are relatively small when we look at the price difference. So, again, just another angle to look at this. So what do we do here? So let's test whether or not feature, display, and feature and display are statistically equal to each other. That's how we test it. So we have to put the indicator 1, 1, 1 when those dummies are on. That's what the 1 means. So the null hypothesis is that the effective feature is the same as the effective display, which is the same as the effective feature and display. That's the null hypothesis, is that all 3 promotional effects are the same. Very small chi-square value, very large p-value, so we reject the null hypothesis that all 3 promotional effects are the same. You can also test the interactions, which are the slopes. Again, here we're saying that the slopes are all the same, and we're rejecting that as well. You can also use test arm. Yeah, test farm does the same thing, except to make them equal, you just list them. You don't have to put the equal sign. You just list them, and then at the end you put equal. So again, it just does the similar test. It's actually a little bit different test, but you get similar results. All right. So what we want to do, what I'm going to have you do is what I'm going to have you do is a couple of groups of graphs. So we're going to do probably 4 groups of graphs. We're going to do kind of one group, which is the Heinz promotion, which we already did. We'll do another group, which is the one's promotion. Then we're going to answer some other questions, such as, I think we might, yeah, something like, what happens if Heinz is on feature and Hunt's is on feature? Do those cancel each other out? So starting from that, right, no promotion, so here's with no promotion. What happens if Heinz and Hunt's is on, are both on feature? One of three things can happen. Either the Heinz feature dominates the Hunt's feature and it shifts it out. Either the Hunt's feature dominates the Heinz feature and it shifts it back. Or they what?
They cancel each
They cancel each other out, and there'll probably be some difference, but we'll need to see what it is. It's probably not going to be a statistically significant difference. So that's basically what we want to see. What happens, and then we can do this for what happens when we're on display and they're on display. We're on feature and display and they're on feature. So the competitive promotional aspects. And a lot of this just has to do with changing your margins. So in this one, well, let's do a couple first. But what we're going to want to do then is we're going to have, let's see, we're going to have these groups of graphs. We're going to have these groups of graphs. We're going to have a ton of graphs. What we want to do is combine that so that we don't have a ton of graphs. So we want to be able to minimize that and give ourselves, so we open a tab up. So I'll send you the
It's
Tableau.
weird, right?
What happened?